So number 10 says to write the perimeter of a triangle, or what is the perimeter of the triangle with the given vertices. So we do want to graph this to see what we're looking at. So I'm going to go ahead and put this graph to the side here. Usually you want to do this on graph paper. I'm going to be careful to do this here on the paper. So I have -1, 1, 2, 3. And then I have 0, 4. So we got 0, 4. And then I have 0, 3. So here is what we've got, a very tiny little triangle. So what we're going to do is we're going to find these different units. Now I can tell that this segment here, it's just 1 unit over, that's going to be a side length of 1. And I can also tell since this unit goes up 1, that's going to be a side length of 1. So far I have 1 plus 1 plus the third side here. Now, I also notice here that since this is a horizontal line and this is a vertical line, those are opposite reciprocal slopes, which means that these are perpendicular lines, and if they are, then what that means is that this is a right triangle. So I'm going to use Pythagorean theorem to find that third side right there. So what I need to do is say I've got my 2 legs here, so leg squared plus leg squared is going to equal my hypotenuse squared. That's going to be the C here. And then I want to do 1 squared, which is 1, plus 1 squared, which is 1. So 1 plus 1 is 2 equals C squared. So the inverse of squaring is to take the square root of both sides. So C is going to be equal to the square root of 2. So it's 1 plus 1 plus the square root of 2, which when we clean this up, 1 plus 1 is 2, plus the square root of 2, which is as far as I can go because those are not like terms. Number 11 says find the perimeter of this particular figure here, and when we're doing the perimeter, you'll notice here we're going to actually have to use either Pythagorean theorem or distance formula 4 times to get each of these edge lengths right here. I'm going to go ahead and do Pythagorean theorem on these because I think it's a little bit more simple on a coordinate plane. So here we've got, well, maybe not, I really just cannot see this, so I'm going to use her ordered pairs. So I'm going to go ahead and say distance formula is equal to, and we're going to be using the ordered pair first as -5, 7, and then we're going to be using 2, 6. So we're going to do the distance formula here of x2, so the second x, minus x1, which is -5, squared, plus we're going to do the y2 minus the y1 squared. So we'll clean that up, and that's going to be equal to the square root of, that is 2 plus 5, which is 7, so 7 squared is 49, plus this is going to be 6 minus 7, which is -1 times itself would be +1, so we've got the square root of 50. That will simplify if you think about that as 25 times 2. The square root of 25 is 5, so we have 5 square root of 2. Now let's do another one. So distance formula of, let's go ahead and get these 2 coordinates here. So I'm going to pull this one to the side here. We're going to be doing 2, 6, and 5, -3. So if we're doing 2, 6, and 5, -3, distance is going to be equal to the square root of, so x2, which is 5, minus x1, which is 2, squared, plus y2, which is -3, minus y1, which is 6, squared. And that's going to give me the square root of 5 minus 2 is 3, 3 times itself is 9, plus -3 minus 6 is -9, times itself would be 81, which is going to equal the square root of 90. And if you think about that, that is actually going to be equal to 9 times 10. Square root of 9 is 3, so we have 3 square root of 10 would be our second distance here. Let's do another one. So distance is going to equal, this time we're going to do the points -4 and 5, -3, so -4, 0, and 5, -3 on our picture. So distance is equal to the square root of x2, which is 5, minus x1, which was -4, squared, plus y2, which is -3, minus y1, which is 0, squared. When we clean that up, let's see what we got. 5 minus -4 would be 9. Squared would be 81. Plus -3 minus 0 is -3 times itself is 9, which is the square root of 90, which we already found to be 3 square root of 10. And we got one more. So the next one, the last one here, we've got -4, 0. And -4, 0 is going to be paired with this -5, 7. So distance is equal to the square root of, let's go ahead and take x2, which is negative 5, minus x1, which is negative 4, squared, plus y2, which is 7, minus 0 squared. So let's clean this up. So that would be negative 5 plus 4, which is negative 1 times itself, which is positive 1, plus 7 minus 0 is 7 squared would be 49, which is square root of 50, which we already found to be 5 square root of 2. So now we have all our information. Now we just need our final answer. To find the perimeter, we just need to add all that together. You want to add the ones that are like terms. So the square roots of 2 are like terms. So 5 square root of 2 plus 5 square root of 2 is 10 square root of 2, because remember you add the coefficients, you keep that square root of 2. Plus 3 square root of 10 plus 3 square root of 10, you add the coefficient, 6, but you leave the square root of 10. And that is as far as we can take that, so that will be the perimeter for this particular figure. On number 12, it says we're going to find the area of this figure, and so we're going to have to more closely look at chopping this up to see if we can actually get these points locked in place. So give me just a second here. And in fact, I think I'm going to stop this video, and I'm going to start number 12 on its own video just in case I make a small mistake here. So if you will go ahead and tune into the next video for number 12.